Good morning. Monday morning. Yeah, yesterday for a short while I ran some tests on this transformer out of this $1 radio chassis here, and as you can see, the bench is crowded again, but of course I didn't get these cameras off the bench. I got the audio output transformer out. Someone asked about the dog bone resistors and the volume control and tone control. They're right here. I haven't heard back on the comments, so if not, I'll toss them. Well, I won't toss the volume controls. I toss the, I don't save dog bones. You know, they're not worth it. The Dawson camera, before we get on to the radio here, the Dawson camera, this is the shell that just slides off, is dead. I removed the LED, had a job getting it out. It's held in by 3 micro screws. This wasn't. This was held in around the lens with a rubber gasket. That works. You put 12 volts in it. So I'm hanging on to that. Probably never use it. And this is the camera assembly here. These are things I can't work on. It is dead. Totally dead. So I think it got knocked out by lightning. But anyways, before we get on this here, as you can see, I got the clip leads on here. Last night I ran some quick tests on it. With 100 volts going into here, through the variac, which is all turned off now, I'm getting 570 volts. Let's say 570. I have to think there. 570 with 100 volts. The limit on this meter here is 600 AC or DC, so you don't want to exceed that. So I think this transformer may work very well for the power supply. I took this out on the bench along with this monitor. Let's see, a couple nights ago I think it was. One day went into the next. And I can see it lights up the whole yard, really, and a night vision. And I can see things much better with this. It's not dark. It is much clearer. However, it's very grainy, which is understandable, but it looks like a far better quality camera for night vision. I don't know about daytime. I tried it. It looked good, but when you're looking at this in the daytime with that outside on the bench, it's really hard to see. But I had that at night. I had extension cord on it. I had the camera out there. I was powering it up with the wall wart that I put the larger capacitor in, which is right here. And it's pretty good. Now, when I went to Jewett City to get this, my intention was to hope to find some coaxial cable, but no luck. Very rarely do I see that stuff, and when I do, I don't need it. And there's no room to store it. I'd have to throw it outside on the ground in the back of the shed. So I avoid picking up stuff that I can't use right away or maybe never use. But anyways, that's a future project that will probably be mounted on the shed in the future. Okay, what this video is about is this radio and stripping the chassis. First of all, the audio output transformer is for 6K6. There's 2 6K6s in here. Here's your primary right here. I have not tested this. I have never seen a secondary blow out. You know, that's just not going to happen unless it disconnects inside here. But this winding, solid copper wire is the actual winding that is on the secondary. On the primary, yes, you could have a problem with it, and it's not exactly in beautiful shape. It's kind of an unusual mounting, where normally, if you look at the transformer, it would have an ear coming out over here, but it doesn't, so it would mount this way. So this mounts this way on the back of the chassis. I was reading the comments this morning on this radio. It's either ZB 1971 or He's the Master. One of those two guys, and they're both very helpful. But I don't rely on my memory because it's no damn good. One of them said that it's a GE. They gave the model number and the chassis layout, including the offset IF can. That's probably what this is. Okay, that's fine. On the power transformer, I'm going to try to get some light in there. It's not very well lighted, so let me set up a light here and I'll be right back. Sorry about the handheld stuff, but there's way too much stuff on the bench to set my little tripod up, which is being occupied by this guy right now. So I'm holding as steady as I can. Okay, let me get my hands in there. I can do better than pointing. This is the 5-volt windings, okay? This is the 5-volt windings for your 5Y3. I mistakenly called it a 6X5, but it's a 5Y3. I think I mentioned that in either this past video or the one before it. I don't remember. This is the 6.3. This is your secondary, and I got those taped off for very good reason. Okay, you get 500 volts on this, and that's what 110 going in here through the variac. I don't seem to be drawing any current, noticeable current. Maybe no, I don't even think I'm drawing 100 mils. Now I have an insulation tester that I got on eBay several years back. Takes 6 AA's. I don't think I got 6 good AA's. I have used ones. I stored it without the batteries and they're very hard to put in. It's put in the back somewhere on one of the shelves here. I was going to run an insulation test on this. Now, the way this is set up, I don't know why I don't put my glasses on. All right. The way this is set up, this wire here is most likely the center tap for the high voltage. Okay, I'm not 100% sure. That goes to the chassis. You can see it right here. Right there. Then you got 2 more wires which are stuck together with wax, and that's what I wanted to point out. Right here. That's a clump of wax right there. So that transformer was overheated. There's all wax up in here on the surface. It's sticky with wax. You can scrape it off with your fingernail. So it's been overheated in the past. The wires look okay, and I'm not one of these guys that'll take the transformer apart and try to rewire this. No, I will not do that. These wires are not frayed that I can tell. I'll know better when I take it down out of the chassis. I will be removing it. It's got mounting bolts right here, and that's part of your grounding, I guess, too. And you got 4 bolts and can remove it. Your 6X5 was right here. Here we go again with 6X5. 5Y3, 5Y3, 5Y3. Damn this mind of mine. Oh, I can't correct myself when I'm using Sony Movie Studio 13. So if I say something wrong, I can't add the correction in text because I can't get it to work. in Sony. I can only do that in Movie Maker. That's why I love Movie Maker. It's so much easier. But anyway, that's beside the point. 5 volts here. So what you got is your 2 5-volt windings. You know, in other words, that goes across the filament of the 5Y3. And this winding has to be able to take the 450 volts or whatever this thing will put out between here and ground. In other words, it cannot break down. So I need to probably verify that. If this transformer is going to be used with another 5Y3, or if it's going to be used with 4007, 1N 4007, then it wouldn't use this winding. The 6.3 has only got one wire here, and I hope I was on camera there because I'm looking at the chassis and not looking in the camera. Great bad habit I have of doing that. So the other half of the 6.3 is obviously grounded here, so that's the way the filaments are wired. The same with the center tap of the power transformer. Okay? So right at this point in time, we're leaving this connected. And like I say, running 100 volts into this gave me 570 volts. You know, I have to think. Is it 470 or 570? Whatever I said on the comments, that's correct. Things are fresh in my memory, it's okay, but my mind is like a sieve. When stuff goes in, a lot of it leaks back out again. And it's very, very frustrating. Surprised I passed my radio and TV course years ago. If I keep doing things over and over, I'm okay with it, but, you know. But anyways, this is a lot of wax. And this is like wax plugged up here. But the wires don't seem to be brittle and cracking. So what we're going to do here on this video is I'm going to put this back on the meters. You notice I got the wires all stripped. I'm going to run the high voltage test on this. We're already verified. You take my word for it. This is 5 volts. Actually, it's over that a little bit, unloaded. This is 6.3 with reference to the chassis. If you reference this one lead to the chassis, it's 5 point something volts, and it's about 4 point something volts from chassis. But these are not supposed to be referenced to chassis. There is no tap going to ground on the 5Y3. I got to think of it. 5Y3. This is the high. This is the DC output. In other words, your 5Y3. Your 5Y3 is a directly heated filament, cathode coated. I have not tested these tubes yet. Got them all down on the floor where I can step on them, but I haven't got no room. I got to find a box to put them in, but I want to test them first. And then I'll put them in with my other tubes. Those are the tubes I removed from that, what I was told is a GE radio. So what I'm going to do here is I'm going to set up this meter over here. I got to clear this bench off. This is what's left of the Dawson camera. I unscrewed the top. There's nothing in it. I took it out, but I saved the shell in case I want to put something else in it. The cabling is fine. So we got to get rid of this stuff for now. We got to make room here. And I haven't removed all this, but I'm just going to toss this. The only things I might save is the micas But you know, the chances of me using those again or anything like that is very slim because I don't do that much radio work. I removed, as you notice, the push button assembly, which is over here with the coils. Came out with just 2 screws and clipping some wires. It could be used for replacement. Somebody may need it. I will hang on to it. If anyone needs any of this stuff, you must leave your email address and you must pay shipping. I'm not asking for any money in this stuff at all. As long as you're in the 48 states, if you want to pay the exorbitant, yeah, I can't even talk. The outrageous high prices to ship out of the 48 states, well, I need the money for that first up front. And I'll be more than happy to send it to you. I wonder if that's got banged in there. The coils, the end of the coils. Anyways, it's got the trimmer caps. They look pretty good. So, I'm saving that. I'm going to remove this coil. There's a lot of rubber-covered wire in here. Not all of it. There's a row of trimmers right here. I may save that. They're just on with twists. You just give a little twist here and that'll come right out, clip the wires. The oscillator coil looks to me like it's got wax all over it, but it could be waxing from this cap here. What I'm going to do is just strip it out, take the wires out, throw all that garbage out. The wax caps have been in the garbage here. Carbon comp resistors, I'm not even going to bother, but what I'm going to do is cut everything out so it'll just be a shell and I can throw it into the scrap metal when I bring it down to the transfer station and just dump it in the metal bin. I don't bother saving tube sockets. I used to years ago. It's too much trouble drilling out the rivets. It's not worth it. It's too much work cleaning out the tube pins. I do have a small box of new old stock tube sockets anyways. I don't need this. And these wafer type tube sockets are not all that great anyways. There's a lot of it I'm not saving. The dial cord became unhooked. Yeah. See that, Ron? There was a pulley that came off of, I think it was here. Not sure. Somewhere in here. That the dial cord went around and it was off. This, I'm thinking, it'll fit a 1/4-inch shaft. I'm thinking of on the Crosley, which is right here. You see what it... See this? You just remove them 2 screws and you take that out. I'm figuring on sliding this pulley, see it? A wooden pulley. After I take that bracket out, slide the wooden pulley on it, glue it on the shaft, and then I can put a rubber band around that and it might turn it. I told you, my mind is working all the time on that. And not only that, but the dial cord, I will probably gently take it off, try to get it off. If I can avoid cutting it, just put it in a little bunch with the spring and drop it into something, maybe in this container here, and just keep it. There's more dial cord here than this radio needs. But I'm not going to string it. I'm going to Rube Goldberg it. I just got to glue that wooden pulley on the shaft of the Crosley. Okay, that's another story. All right, I'm not sure if you're going to be able to see that meter. I can't seem to get rid of the reflections because the camera, again, is in a very, very awkward position. I cannot see the side viewer. I'm using the JVC. I'm taking off my safety tape. This is the 500 volt plus secondary, very dangerous. We're going to be clipping on the meter. Onto that. And leads, we'll just lay this here. I don't even know if it's blocking the view or not. We're laying this flashlight across here to keep these from shorting out. You know, it's very dangerous. Don't try this at home. You do so at your own risk. I've been doing this stuff for years and years and years. And I know what to touch and what not to touch. Okay. What I'm going to be doing now, you'll have to take my word. I can't show the voltage going in. You're going to have to take my word when I say 100 volts is going in. We're going to start all the way down on the variac. We're going to put the power on. And got something going on outside there. Coincidental, as soon as I turned the power on, hearing a buzzing sound. I got the door open a crack. It's very stuffy in here. Not sure what's going on outside, but all right, I'm going to turn the meter on. Now I want to look in the I don't know if you can see that. I got to get a magnifier and look on the viewfinder. I'm standing up on a very awkward angle, which is always the case with me. I think it says auto in there. Right now it's reading ohms because it's reading 177.2 ohms. That's the resistance of the secondary. But this meter here will read that until you apply voltage, and then when the voltage goes up to a certain point, this background will light red, indicating it's a hazard voltage. Okay, so we're all set. No other wires are in the way. We're going to put the isolation transformer on, and we're going to flip on the variac, and when our reading 3.2 volts now, because the variac is turned all the way down. Are we still recording? Yeah. Okay. Very inconvenient, boy. I sure get my exercise jumping up and down the chair to see the viewfinder. The things I do to make videos for you guys. But I enjoy it. Okay. All right, so take my word for it. We got 35 volts going into the primary of the power transformer on this radio chassis. And we've already got 125 volts coming out of the secondary. I think you can see that. I hope you can see that. Let me once again jump up and look at the viewfinder with a magnifier here. I think so. Yeah. Okay. There's a symbol on the screen of the camcorder, and it's blocking the voltage reading. Okay, but you won't see that in the video. That's part of the menu that is there, the display. Okay. All right, so we've got 35 volts going in. Now let's put it up to 45 volts. So we're up to 230 volts right now on the secondary, and you can see the display lighting red, of course. Now, when I reach 570 volts on this with 100 volts going in, I did not push up anymore. I didn't try to put 115 or 120 in it, because I could exceed the limit of this meter, which is 600 volts DC or AC. You don't want to exceed that. You want to make a test like that, you use a vacuum tube voltmeter. I'm not sure what my Fluke 73 will read, but I think it's probably about the same. I'd have to look the specs up. I do have the book on the Fluke 73, believe it or not. All right, now, that's with 45 volts going in. Now we got 50 volts going in the primary. 50 volts going in on the primary. 280 volts. I really have to, I'm looking at the meter on an angle, like everything else. I need to go look straight on, which I'm going to do now. Sorry for the ugly head. 280 volts, 279.5. It's a variation in the line voltage, of course. Okay. All right, so now let's go to 70 volts, 70, going into the primary. We're already up to 402 volts. And we're not drawing any current. We shouldn't be. That would mean we got a shorted winding on the primary or secondary if we had a current drawer. Now, an unloaded transformer, I believe, will draw some current, but usually on the initial startup, when you first apply power, but not continuously unless you have a load on it or a load due to a shorted winding. All right, that's 70 volts. All right. $60 volts. No, 80 volts. 80 volts. The hell's the matter? I can't even read the meters anymore. 459 volts on the secondary. There's your frequency right there. 60 cycles. It's been reading 59.99. So this time it's reading 60. The kilowatt always reads 60. It never reads lower than that. Okay, now let's go up to 85 volts. Now let's go up to 100. We won't fool around. We'll go right to 100. Exactly 100 volts going in, no current draw whatsoever. And we're 572 volts. Okay. Remember I said 570, but I couldn't remember if it was 470 or 570. So we're getting close to the upper limits of this meter. I don't want to push it because I could zap it out and I'll be without it. So we're going to go up a little higher, but we're going to monitor this very, very carefully. So I am going to turn it up. $595 volts. We're not going any higher than that. We're not going to damage the meter. I've got 104 volts going into the primary, and I'll show you that right now. Okay, no current draw. No current draw on the digital meter. No current draw, take my word for it. It's down there on the left side of the variac dial. No current draw there. So that's what we're getting. All right, now we're going to switch off the variac. I'm not going to change it. I'm just going to turn it off. The meter goes back into auto and it's reading ohms now. I think you can see it. I moved the camera a little bit. So we're going to take off. Can you see that? I'm moving my hand because I have to be able to see in the viewfinder. Yeah. Okay. I'm taking off the secondary. There's no power going in it. We're going to read the 6.3, which goes from ground because of that grounded, those wires that I showed you in the beginning of this video. Half the 6.3 volt winding goes to ground, and this is the other half of the 6.3. All right, so now we got to move this. All right. We're going to flip it back on. Now we're not probably going to get a full 6.3. We only got 104 volts going in. Well, let me put it on. .18. Okay, remember, we're only feeding in 104 volts in the primary because we didn't want to zap out this meter. So I can guarantee you this secondary of this transformer will put out a little over 500 volts AC. Of course, it's going to be rectified full wave. So you're not going to get 500 volts out of that. The only way you would get 500 volts out of that DC would be a half-wave rectifier, ground one leg of the secondary, put a diode, a half-wave, just one diode in it, and that'll give you your full 500 plus after it goes through the electrolytics, and I don't have electrolytics that'll be that high. So my feeling is this transformer using a full wave rectifier similar to what the 5Y3 is set up to do will probably give me about 250 to no more than 300 volts after it's filtered, DC, after it's rectified and filtered. So it may or may not be enough for the power supply, and I'm not building a half wave just to get the voltage all the way up. All right, so it's 6.3 there. All right, I'm going to shut the variac off because I've got two bare wires sitting right there on the bench to the right side of the green leads. There we are. And we don't want to hit them. Okay, now I got the meter back on the secondary. I have not touched the variac. The meter's indicating 178 ohms, and we're going to put it back on voltage. .595 volts, 104 going in. So we can't go over that. We can't even put 110 in because it's too risky. Don't want to damage the meter. So that's what this transformer is going to be putting out on the secondary. Over 500 volts from end to end. Remember, end to end. Between center tap and chassis, let's find out what that voltage is. So we're going to take one lead off and put it to the chassis. I can't find my pointer stick, use my finger. This here is the center tap, right here, goes to chassis. We'll flip that off. We'll remove one wire, put it to chassis. $299 volts from center tap to chassis. You see the two green leads? One is to chassis, one is to right here. Okay? Now let's bring this over to here. We'll turn the power off. Okay, we reversed it. Power's off. We were on this side, now we're on this to chassis. Two green wires are going to the meter, which is going to be shorting out over here now. Got to be careful. When you do a Rube Goldberg like I do, which I've always done, it's very dangerous. So let's get you back up on the tripod. Okay, I'm going to put the power on now. Takes a while for that to kick in. 299 volts on that side. So that would seem to indicate it's 600 volts with the center tap. The transformer is running ice cold. I really don't like to leave this going for hours unattended, but not with a meter on it. But if the transformer was going to run hot due to a shorted turn, it would run hot unloaded. We'll shut it off. All right. Safety reasons, we're going to tape up this wire. What I'm going to do next on this, I got to find the end here. I've got no fingernails because I have to keep them real short because they're real thin and they tear. I got more physical problems than the old saying, Carter has liver pills. Carter hasn't had liver pills in years, but I remember that commercial as a kid. All right. So we want to tape up the high voltage leads here. We don't want to brush into them. It would be awful. And then what I want to do, off camera, but not right away, I got more Scotch 33 tape. I got a couple, 2 or 3 rolls of it at the Jewett City Flea Market a few years ago. We just want to make sure that the tape overhangs the edges of the wire, the ends of the wire, so we're safe here. We're not going to get burned on the end of that. Okay, that goes off. And we know that this is the primary. And I have to look in the viewfinder because I have to see if I'm on camera. This is all like stiff in here. Now, if I use this on my power supply, I am going to ground these just like they are here. Right here. So, I think what I'm going to do now is I'm going to take this transformer out. You know, I was thinking before I went to bed last night, because I do a lot of thinking, but I'm not going to do that. If I do make a power supply, first of all, this is not the ideal transformer to use because I'd like one of these top chassis mount transformers with the flanges on the side. This is the kind that goes through the chassis. So I was saying, well, I'll back you up a little bit. As I cut the chassis across here, fold this over and leave the transformer in here, well, remove it to clean it, and make my power supply. But I'm not going to do that. That's a crap job way to do something. So this type of transformer mounting is not ideal for a do-it-yourself guy that wants to build a power supply because there's no way I'm going to cut a hole in the aluminum chassis. I don't have any way to do that other than the saber saw with a metal blade on it. The Dremel tools that I have are way too small for that stuff. I'm not going to do that. I'm going to wait until I get a cabinet. And once again, I want a case like this. Originally, when I bought this meter, I was going to make a power supply out. This is too damn good. This thing works excellent. It's a millivolt AC voltmeter. You can read the output of a phono cartridge on this. You can read the output of a microphone on this. It'll peg the scale on the low range here. This is very sensitive. I'm not joking that. That had one bad tube in it, one shorted tube in it. 6U8, I believe it was. But I want to get a case something like that. All right. Oh, it's hard to see in this shop, I'll tell you. Oh, man, they're on there hard. We'll get this transformer out. Can't see anything. I have no idea how hard it is to see these things. Wires in the way. Wires in the way here. There we go. I had to take a pair of pliers and wiggle the terminal that's connected under that nut there. But these are the wires that went to the ground. There's 3 of them. One high voltage secondary right here, one 6.3, and maybe one 5 volt. I don't know. But these all 3 of these were going to ground, so we're going to just keep them twisted here. All right? That's what went to the chassis originally. Okay. That'll fall out afterwards. Get this transformer out. Yeah, I can clean up some of that wax maybe. You know what happens. Yeah, I figured so. Got a star washer under here that's holding this end from going out. There we go. Okay, let me stop this video a minute here. I got this chassis gonna fall over. Alright, the first thing I want to do, we got a star washer here. So we just put a nut back on here, so we'll be able to use that. It's too bad it wasn't a top chassis mount transformer. You can't have everything for $1. And we just put that on there so we don't lose it. Oh, the whole thing is turning here. That's understandable. Okay, there we go. Now we're missing a star washer here, so we'll drop that on there. And we'll put that in there. That's good enough. That won't fall out. We're missing a star washer here, so we got it right here. We'll put that in. That's where that's your terminal right there, where the ground was. Now, if you can see that, that's why I snapped it off. We'll just stick that in there. We'll put the nut back on there. We'll get this wax off of here, and we'll paint this a shiny black after we clean it out. This will really, really make Buzz's day here. It's not that bad, though. Not really that bad at all. No, it's more rusty up here. Yeah, this will shine like a baby's you know what when this is got a nice coating of black enamel, Rust-Oleum. Oh yeah. Now, let's get you a little closer here to the wax situation here. Alright. We got a big clump of wax that obviously came from inside the transformer, all through here. I'm not sure what to dissolve that with other than heat, and I don't want to do that. So obviously this was overheated. Now, a lot of guys would take the shell off of this. I'm not going to do that. What I am going to do, but not on this video here, is this is the primary. You can see there's some wax right here on one of the primary wires. We know that's the primary. We know this is the hot secondary, which I taped up. These here were on the ground. Get you back a little bit, right there. Okay, so it's a decent transformer, and we will be doing some tests on this. Primarily insulation tests. Now, what I'm going to do here before I close it out is I'm going to put my ohm meter on one of these here and test the resistance, if any, between a winding and the transformer shell. If there is a breakdown there, we're in trouble. Now I've got like I say, I've got an insulation test meter that I've used a couple of times. I got off of eBay, but it takes 6 AA's there. I don't have 6 AA's right now, and they're awful hard to get in. But it works quite well. I believe it puts 500 volts on it, low current of course, to check for very high leakage resistance. But we're not going to do that today. We're just going to do it with the meter here. And from what I understand, this meter here, I think it says 60 megs. Well, I would say 60 megs would be, if we get a reading that is over 60 megs, I'm almost certain will be okay. Okay, so let me get that set up. The battery is showing yellow here now on this JVC. All right. I hope the reflection isn't too bad. We're using clip leads. It's more reliable than trying to hold it on. What we're going to do now is, we've got the lead. I guess I'm in camera. We got the lead grounded. I tightened up the nut here so we get a good ground. So we got one side of the ohm meter to the frame of the transformer, and we're going to test the primary here first for ohms. Okay. No reading on that. Okay. All right. Now we're going to read to the secondary taps. Nothing there. Okay. Now we're going to read to the 5 volt. Winding to ground. Nothing there. Now to verify that we are making a good connection, I'm going to put my hand on the transformer and my other hand on the 5 volt winding. We're reading resistance now, and you can see just through my body that's what we're getting. I can't read that from here. It's a bad angle for me. I have to keep the angle so you guys don't get a glare, so it makes it a handicap for me. Okay, now we got to unhook this again. It's a pain in the neck. I got to get some more tape out. All right, this is the high voltage winding to case. Okay, this is the high voltage right here, one side of it. We'll test the other side to ground. No. Okay, so we don't have any leakage. In other words, we're not getting any resistance between the case and the high voltage winding, between the case and the 6.3 volt winding, which we'll do right now, in case I didn't do it. Okay? Volt, everything is perfect. So now what we're going to do is end this video. And we're going to tape up these wires again. Yes, we'll do that off camera. We got to tape up these wires. It's going to be a while before I'm ready to use this, if I use it at all for a power supply. I would probably have to, well, I don't like a lot of work cutting into a metal chassis to mount this. But regardless, we got to mark the leads. We're going to do that off camera. And worst case scenario, it could be used in another radio that may have a blown transformer. Alright, so this concludes the video on this. We know, I turn this off, that we have, if any leakage at all, it's over 60 megabytes. 60 meg ohms, 60 meg ohms, 60 meg ohms. That's what this meter will read. So, if this had 60 meg ohms of leakage, it still wouldn't hurt anything. Okay? But we don't even have that. We're infinity on the readings. So, okay, that's it, folks. Whew, I got some video editing to do today. Have a good day, everybody. Thanks for watching.